I'm going to talk about recommended counting and Liferay machine learning approaches, and let's just dive into it. First of all, our starting situation is that we have a portal situation with locked-in users where we have a process variety within the system here. We have their information on CMS, on management events, on blocks, on tedding, whatsoever, a variety of processes. Together with that, there comes a variety of data sources here within the Liferay context that we are having currently. We have an older Liferay machine here, which we have, our task is to come up with clever recommendations aside from the fact that we are currently not having something like analytics cloud situations like that. We have mostly on-premise data. So we have a variety of data sources here. All those go together. And our situation was come up with some clever recommendations here on the content that we can do. So starting point is, given that user-specific traits data are lacking here for us, we have not good preferences, no searches, no paths, no click paths, no whatsoever. All those data are not available in our situation, or have been. So the question is, how can this business portal users get highly specific content recommendations on the basis of, well, their usage on, whatever we find within the portal data sources? The problem that we are having here is due to the situation that we have a lot of different data sources here. We have data lakes, we have silos, we have mixed data types, mostly unstructured, a little bit of semi-structured data. We have information on use cases, on some workflows, click paths, notifications, so forth. And basically, it's always the same, that the access, of course, to the data is key for further development. We have something like an idea, like a vision. So what we finally would like to have is a situation like that, where just focus yourself on the yellow rectangle there, where there is something like a potential asset publisher here, recommendations for you, and you see there 3 different recommendations on a kickoff project, critical problem, new employees, whatsoever. And these recommendations here, that would be the vision, are based on machine learning recommendations that we construct, given that we are not having something like, again, user trait data, no analytics cloud yet, and so far. So our idea was that at least we would need from machine learning 2 components, which we which are on the basis of natural language processing. One component is the offline training component that you see on the top, and that does basically crawl through the databases, looks for traits, extracts those traits, and sets them up in any kind of hierarchy or clustering. And then afterwards, in the online prediction part, use those traits from the offline part and match against those and come up with clever recommendation and say something like, I don't know, 95 confidence interval, good recommendation, or whatever might be the case for such an approach. So our generalized architecture here that we kind of came up with is we have something like 7 different steps, and just focus, I just want to walk you through the 5 steps in the middle from the user login. Again, it's a system with locked on users, and then go through that. So that's going to be basically the structure of the talk. First situation is user login. So what we're getting then, in the best case, is information about the user, the name, the location within the hierarchical structure of the business portal, what department does the person belong to, what are co-workers or known associates whatsoever, is there something like historic data available, are there historic click paths, topics, user traits, so on. all of those informations must be accessible. Again, data accessibility here is of course the key factor. The problem then is accessing the data sources, and you see, if you have a look there on the more or less UML diagram there, you see after the login of the user, on the left side external data, on the right side Liferay data. So there is also something like external data which is in the context, which is related here to Liferay. In our case, mostly documents that the users have generated, and I will come to that because that was our key of using here that on-premise approach. Accessing the data sources, of course, key factor is that we have interfaces. If you remember the variety of different sources there in the variety of processes, that's not necessarily too easy. So we are still also in the process of working on that, and I will show you some of the results there. So if we come to the machine learning or AI routines that we use, second step then here, basically it falls into two classes. One is the pre-processing of the data, so that's a clever way of doing some ETL, extract, transform, load. Excuse me. Second is something like the real machine learning approach. And if you come up with a question, what's the difference between machine learning and artificial intelligence, I would answer, if it's written in Python, it's machine learning. But, well, not everyone likes that joke, by the way. Okay, so next is data pre-processing and ETL. So what we're doing here is classically extraction of the relevant data, transformation within a unified database, and then loading the whole thing into the data warehouse. So the processing pipeline here is accessing all databases, might they be internal or externally, generating one unique reference database with, well, not normalized, but with unified data that can be accessed from all of those ML routines, then applying some Boolean filtering to match basically everything necessary adequately that you want to do your recommendations on, and what that yields finally is something like a data mart, which is only one chunk of data from the whole databases. The next step then is, I'm talking too fast, I'm sorry, the machine learning and the word clouds. So the challenge, as I mentioned, is we're currently not in a situation for that customer that we're working to have something like an access to the analytics cloud, though we're working on that. So we're not having something like user trait data, as I mentioned. We have no demographic information. We have basically nothing that we could have from the right side, okay? So what we did then is, or what we had to challenge then, how do we create then something like user-centered information, user traits? And now comes the AI or ML routines that we use, and that's basically, we first of all use something like word clouds, which is something very intuitively that you can understand. So what we did then, we used external databases that are related to the system, and these are databases, for instance, where the users from the system, from the Liferay system, do have something like PDFs, like docs, where they document their work, where they have, I don't know, proposals, where they describe their work, where they have small chunks on news that they've written or events that they've been to or whatsoever. And we use those things for creating user traits and behavior, creating some kind of work paths, which we did then. And the way we worked on that is we had a processing pipeline then, where we first of all did something like, well, classical NLP, natural language processing. And that falls into, first of all, analyze the documents, ID stop words, which are words which have no really interesting contribution to the context of the whole situation, like conjugations, like and, no, whatsoever, like articles. Then create tokens then, so single words, tokenizing. Then do, for instance, identify the words that always come together, like, I don't know, like human resources, like research institute, like whatsoever. So combinations which are classically in the context of the business portal, for instance, and play a role there, and have these joint wordings, then do the lemmatization, for instance, go back to the word stem and do lemmatization, and identify then whether it might be a noun or whether it might be a verb whatsoever. And then use those informations and create user vectors. And these user vectors then were or are visualized. So how does this visualization look like? Well, first of all, we did an approach that is very intuitive in that context, word clouds. So you visualize information with adopted keywords and you arrange them in a kind of a display. So you ID the keywords, you display the probabilities they're in size, meaning if you have a word cloud, the bigger the word is, the more likely it is, the more probable it is that it comes within the whole context of the user. And then you also can do something like word clustering, like the words that are coming together, that are very big, that are very important here for the description of the user situation, and then display these distribution. If you're doing a simple example here of information that you find on the official Liferay homepage, by the way, you get a word cloud like that with the methods that we used so far. And you get Liferay, you get Python, for instance, you get database, you get collaboration, and you can use that for describing approaches and visualizing here once you're having documents, PDFs, information on home pages whatsoever that you can run all the NLP routines with. So, what we did then is we used these word clouds as references, and we used the external data, took the PDFs, took the documents, all on premise, created the word clouds, and what we then did is we redo the prior procedures that we did for the external data, for the documents, and matched the internal databases within the Liferay, and created then probability vectors. How likely it is that someone who has a word cloud that was constructed on the documents, on the PDFs, for instance, how likely is it that within the Liferay context, the events, the whatsoever, whatever might be in there, would be interested in something like that, okay? And then we display the results for the databases. As well, for disclosure reasons, I cannot show you that database that we are working on because the customer probably would not be too happy about that. By the way, background of that is 3,000 users, 20,000 documents, I don't know, 500, 600 projects, big databases offline. And the method here runs pretty quickly. And what I'm showing you instead of that is an experiment that we just did last week to show you in what direction something like that would go. So what about Liam Neeson? What we did is, due to the lack of to the fact that we cannot show you the original data here, we just accessed the international movie database, and we applied the methods there to, in this case here, one actor, Liam Neeson. We grabbed all the information, all the text documents that we had there on the page, for instance, and on the plots, on the casts, on the co-authors, on whatsoever on text is available there. And then we ID'd the keywords, we displayed the probabilities, the likeliness that some of those things would appear if the name Liam Neeson comes up here on the IMDb. We displayed this at word clusters, and then we did on the basis of that recommendations. So what finally comes up is a word cloud like that. So next step could be, for instance, that you could mouse over that, you get probabilities and likelinesses that, I don't know, Brian or Batman or Bruce or whatever, here in the context, how likely it is that that appears in the context of that database structure in the background for Liam Neeson. And a next step then could be, for instance, a probability distribution here, which is the probability distribution for the words that we analyzed on the texts, on all the texts that we found, for instance, for that user. By the way, IMDb is pretty large. I don't know exactly how many actors are inside there and how many movies, but it's really pretty big, and it's a nice item that you can play with from the data science aspect, because it's very complex text information. So that's why we used it. And yeah, what you then get is a probability distribution. So how likely it is that Brian comes up, or Bruce, or whatsoever. So these are the movies that we plugged into there, and you get that distribution there. What we finally then did on the basis of that is come up with some recommendations for the actor. In our case, the user Liam Neeson, and we recommended directors, genres, whatsoever, on the basis of the information that we found or that the algorithm analyzed on the IMDb. So that looks like that. So we get 5 different genres. We get directors there like Christopher Nolan, like Peter Berg, and so forth. And we get recommended co-actors for Liam Neeson. So that would be something like recommended co-users, co-workers within the department, for instance, that you would work on with Liferay on, or there's a variety of possibilities that you could do, or that you can apply that to. That method is, as I said, for lockdown users. It works on premise. It works with very large databases. It's written in Python. These are not something like copied algorithms. We developed all of that by ourselves and applied that. We are currently in the process of transferring, of migrating that whole thing from Python to a different, to the possibility that we integrate that as a chunk within a certain Liferay portal for a customer. And yeah, it runs within 50 milliseconds. So there's no cloud connection there. That's the reason why it's so quick, of course. But it runs very, very quick. Within 50 milliseconds, you get in big, big databases, you get the word cloud, and you get the recommendation. It runs mostly so quick that because the word clouds are very similar, if you look on that, if you stay just with one color table, then you are not recognizing that it's a different user if you choose those by random or whatsoever. Yeah, so far. So to sum that up, the idea was, as a business portal user, I'm logged in, and I would like to see relevant articles, documents, projects for me on my personal homepage on the basis of, for instance, text mining, text NLP, text-based whatsoever algorithms. And I come up with recommendations here that I can present in a way like I did. So the method is you start with the data pools on the left upper side. You filter the data, you do ETLs with that, and a little bit of ML methods. You do linguistic pre-processing. You calculate user vectors on the basis of the external or internal database. You fit then the models on that. You have likelinesses that on the basis of the documents with the PDF or the docs or whatsoever, how likely it is that certain content chunks are fitting to that certain user. Then you compare that user vector to the internal database within the Liferay system. That's almost the final step. And then you finally display the whole thing in a word cloud. You hand over the probability so that the user can also check how likely it is. Why do I have written I don't know, Brian or Bruce or Batman or whatsoever that was, for Liam Neeson, of course, in that case, written on my homepage. And then you get the specific recommendations that very, very well fit to the first part of the vector. And yeah, that's basically so far all. Thank you very much.